All right, hello and welcome to Lab 10. We're finally in the double digits. So this one is all about square roots as promised, and we're going to calculate them from scratch, which is pretty impressive. Okay, so the way we're going to do it, again, is we're going to use that kind of binary search process where we're going to make a guess in between two numbers that we know should hold the square root. It's somewhere, and then we're going to refine our guess piece by piece, little by little. All right, so get all the fancy code. This is all the files you'll need, and let us begin. So the work that you'll be doing mostly will be done in squareroot.cbp. So let me show you this library that you'll be implementing. So let's go to squareroot.h. Squareroot.h has two functions, okay? So you're not allowed to cheat and actually use the square root function from the math library, so I've tried to get rid of that. So what you'll do is you'll implement approximate equal. So this gives back true if A is really, really close to B. Okay, so you'll have to use absolute value, see if two numbers are very, very close to one another. Okay, that's approximate equality. And then you'll use that in this function, which is actually calculating the square root of some number x, okay? It gives back that x, even if it's a decimal number. All right, so you're going to go and implement both of these in squareroot.cpp, and I've made stubs for you right now that give back silly answers. All right, so yeah, the idea of square root is let me try and explain this again. Okay, so what you're going to do is you're going to make a bunch of guesses until that guess that you've made, and it took a while to get there, maybe, is finally approximately equal to the square root. And you can check that, okay, by squaring your guess. All right, so you will continue to get closer and closer as you like chop off your search space. You'll find like a mid element and decide to search upwards or search downwards. And one thing that you should be on the lookout for, and something that the test will guarantee, is that you can't find square roots of negative numbers, right? Those don't exist for the real numbers, so you'll throw a runtime error if the user gives you a negative x. Okay, so that's what I want you to keep in mind. And so let me talk about the strategy now of square root. So the idea is, the reason you can search in the way I'm about to tell you is that the square root is always between 0, right, and the number that you're starting with, okay, or 1, if 1 happens to be bigger. So, for example, the square root of 5, we're not sure where it is originally, but we know it's going to be between 0 and 5. That's just how the square roots work, right? So if this is our original range, low and high, we can then put a midpoint in the middle and check if 2.5 is correct, okay? So you'll keep on checking and seeing if your current midpoint is close enough to the square root, okay? And the way you'll check that is, like if mid equals 2.5, the way you check if that was a good enough guess is you'll say, is mid squared very close to the original number that you're searching for? Is that equal to x when x is 5, okay? And so 2.5 isn't good enough, and you'll have to make a smaller guess, right? Because it's a bit smaller than 2.5, but not by much. So yeah, at the very beginning, your search space should be between 0, that can be your lower limit, and your upper limit should be the max of 1 and x, or x plus 1. And the reason you have to use max like this is because remember that the square root of a number between 0 and 0 and 1 is actually going to be greater than that original number, okay? I don't remember what it is, but it's greater than 0.25, which is weird. But that is the reason why you have to use max like this. Okay, so that's your upper limit, and you could cheat and just use x plus 1. That would also work. That's totally fine. So after that, it's your job to find the midpoint, right? So if this is your low, if it's 0, and your high is like 5, you're going to then make a guess, like check the mid being 2.5, and then see how close you were. If your guess was too high or too low based on the original number. Okay, you'll decide whether or not to go up or to go down. Like in this case with the square root of 5, you'll replace high with the mid, right? 2.5 will become your next high because the square root of 5 you'll discover needs to be between 0 and 2.5. Okay, so yeah, that is the idea and the strategy. If it's still not making a whole lot of sense, what I've done is given you the exact way that this program that you're about to write will find the square root of 9. Okay, so I've written a bunch of little examples. It'll be a loop. And here is the iteration that will happen if you give it x equal 9 and ask it to find the square root. Okay, you'll start your lower limit at 0 and your upper limit at 9, and then you'll calculate the midpoint, and that's 4.5. And we know the square root of 9 is 3, right? So we'll notice that mid squared, that's 20 something, that's way bigger than the number we're trying to take the square root of, bigger than 9. So that's too high. We should guess lower. Let's change our upper limit, our high, to be our mid. Okay, so now in the next iteration of this loop, the lower limit stays 0 because we know it's between 0 and 4.5 now. So the upper limit is now 4.5. You'll calculate a new mid. Okay, and that squared is going to be 5 something. Okay, and that one's too low because we're trying to make it so that mid is our guess for the square root, and its squared should be very close to our original value, our 9. Yeah. So this was too low, we'll guess higher. We'll change our lower limit this time to be the 2.25. And so now in iteration 3, we're guessing between 2.25 and 4.5. You see how it's rapidly converging? And so then we'll calculate the midpoint of that, 3.375, and that's a little bit too high. So again, we're going to change our upper limit, okay? Because we now know that it's less than 3.375, the square root, so we might as well guess between 2.25 and 3.375. See that? So it's just a game of calculating the midpoint of our current limits and figuring out which side the real square root is on. Okay? You'll keep on getting a bit too high, a bit too low. You'll be cutting off your range that way. Okay, so now we're already down to almost 1 away. Like the distance between 2.25 and 3.375 is 1. We're rapidly getting numbers out of our search space, so we're converging. Okay, and so this continues for quite a while until we're happy with our answer. And so it looks around iteration 24. Here are upper limit and lower limits. We guess a little too low, and so we'll change our search space. Okay, to be between 2.999 all the way like that and 3.00000 like that. We'll calculate the midpoint. It turns out to be that, and that is close enough for us. Okay, and so mid squared is close enough to 9 with a prox equal, and this mid, this value, this 3 something, will be our answer. Okay, and that's how you find the square root. Okay, hopefully that clears everything up, and that's what you're going to do. So that's how you're going to implement it. And make sure to throw that runtime error though. First check if x was less than 0. And the way for you to determine whether or not your guess was good enough is this approx equal. And let's say that you should return true if the two numbers a and b are within like this many decimals away from each other. 0.5 zeros and then a 1. Yeah? Let's try that. And that's a very accurate answer then. Okay? That's how we can discover the square root. And so that is the bulk of your work. Okay, after that you write a couple tests, and that should be a breeze. Okay, so square root test, I've already written 3 tests. So this is testing the square root of 2, the square root of 0.5, and then the square root of a negative number, making sure that you threw the exception. So get those passing, and then it's your job to write 4 more tests in this kind of style. Okay, they can be about whatever you want. You can check that the square root of 9 worked out, okay, in this way. So that is the idea. So write 4 more tests just to confirm or strengthen your assumption that your code is correct, and that is your lab. Okay, so you'll submit the files that you changed. And one more thing before we go. I have given you a make file this time to actually go and compile this. Okay, so you're not going to say G++ anymore. You will use the make file. Okay, so here's what it looks like, and I encourage you to study it. This is what it looks like. It's making all those .o files and the actual executable file. So to compile this, you can just say, where am I saying it? Make square root test, or even make, because square root test is the first rule. Okay, so, and you can just keep running this same command, and it'll recompile what it needs to, depending on what you changed, and you'll run the test file as usual. Okay, so that is officially everything, and here's the rubric and everything. Please yell at me if you have any questions about any of this. I hope that this little example here will make it easier for you to decide what to do. It'll be like a loop that breaks out when you're finally close enough. And yeah, that is your lab. Hopefully this is exciting. It's a fun little example of what you can do with a computer to like calculate values that you might be interested in, like to make your own calculator. So that is lab 10, and that's all I got. So I will see you next week.